Good morning, friends. Yesterday, we were discussing about this methodical evolution in product design. Why still most of the students have not connected? Prajwal GM.
Yes, sir.
ಯಾಕಪ್ಪ ಎಲ್ಲರೂ ಎಲ್ಲೋದ್ರು?
ಸರ್ ಬರ್ತಾರೆ ಸರ್.
ಎಲ್ಲೋಗಿದ್ದಾರೆ? ಬರ್ತಾರೆ ಅಂದ್ರೆ ಕ್ಯಾಂಟೀನ್ಗ?
ಸರ್ ಇಲ್ಲ ನೋಡಿಲ್ಲ ಅನ್ಸುತ್ತೆ ಸರ್ ಅವರು.
ಏಕೆ ಫಸ್ಟ್ ಅವರ್ ಕ್ಲಾಸ್ ಇರ್ಲಿಲ್ವಾ?
ಇತ್ತು ಸರ್.
ಮುಗೀತಾ ಇಲ್ಲ ಅದು ಇನ್ನೂನು?
ಸರ್ ಮುಗೀತು ಸರ್.
ಮುಗಿದು ಎಷ್ಟೊತ್ತಾಯ್ತು?
ಸರ್ ಇವಾಗ ಒಂದು
10
ಮಿನಿಟ್ಸ್ ಆಯ್ತು ಸರ್. 10 ಮಿನಿಟ್ಸ್ ಆಯ್ತು ಸರ್.
ಓಕೆ, 5 minutes or 10 minutes, whatever it may be. ಈಗೀಗ ಜಾಯಿನ್ ಆಗ್ತಾ ಇದ್ದಾರೆ ಎಲ್ಲ. ತಿಂಡಿ ಮಾಡ್ಲಿಕ್ಕೆ ಕ್ಯಾಂಟೀನ್ ಹೋಗಿದ್ರು ಅನ್ಸುತ್ತಲ್ಲ. ಮನೇಲಿ ಇರುತ್ತಲ್ಲಪ್ಪ ಕಿಚನ್. ಪ್ರಜ್ವಲ್
ಸರ್,
ಮನೆಯಲ್ಲಿ ಕಿಚನ್ ಇರುತ್ತಲ್ವಾ?
ಎಸ್ ಸರ್.
ಅಲ್ಲಿ ಹೋಗಿರ್ತಾರೆ ತಿಂಡಿ ಮಾಡ್ಲಿಕ್ಕೆ. ನೋಡಿ ಈಗ ಎಲ್ಲ ಜಾಯಿನ್ ಆಗ್ತಾ ಇದ್ದಾರೆ ಒನ್ ಬೈ ಒನ್.
Sir.
Okay, yesterday we were discussing about this methodical evolution in product design. See, the same thing since we have started this subject of PLCM, that is product life cycle management. The same thing we are discussing again and again, and the examples are also the same. Only the thing is the approach or the way we look into the topic, that is only different. Other than that, all the things are same. Only based on the question or the title of the question, you need to write the answers by taking that different points, or maybe taking the flow diagram, like that you will be writing. Other than that, most of the things, the concept is same. That is what we are discussing from the beginning. Yesterday when we started discussion of this methodical evolution, at that time we were talking of traditional method or the traditional approach in the design. See, we were talking that around 30-40 years back, they were going with a certain method which is called as traditional method, and even today with the modern tools, that is software, the infrastructure, equipments, everything. Yes, nowadays we can do it more accurately when compared to some 30 years or 40 years back. But still now also we are going in a traditional way only. Why? Because when we were discussing the steps in product design, we were telling that product design, we said that the first step, what was that first step? Concept generation, all those things. The good product design is the first step in the success of the product. That is what we were discussing. I hope all of you remember that the success of the product remains with the good concept generation and the good design. If we fail in that, then we cannot assure the success of the product. So first step is more important. What is the first step? I thought everyone is attending the class and they are remembering that. See, we were discussing about this engineering design. A good product design is the first step for the success of the product. Then after the good design, next comes the manufacturing and production. See, manufacturing and production. Manufacturing means where you will get all your tools, dies, etc. ready for the production activity. That is the manufacturing stage. And the next, the production stage, then sales and distribution. Through your dealers, like that. Your logistics, where you can send your product to all the places, that is distribution, then marketing, sales, service, they all are important, but a good product design is the very first step for the success of the product. That is what we were discussing. See, so we adopt this traditional product design approach for the design of any product. Why? Because this enable us or support us in a well-structured, sequential, step-by-step process, and there will be a lot of discipline will be there, lot of control will be there over the design process. So there are 6 steps in the product, 6 or 7 steps in the product design. So all of them will go one by one, so that there is no coming back. Because yesterday, means in the previous class also, we were discussing about the what is that topic of feasibility study. We were discussing the feasibility study, because after completion of entire design of the product, we must not face the product is not feasible for the intended usage. Means you have designed the product for certain usage, like for washing the most dirty clothes, but while screening the concepts or concept screening, you have selected the different components from different concept, which is most economical, simple, everything, but it may not be able to wash the most dirtiest cloth. Means in the feasibility, it will not work out. Means, so if everything is gone in a systematic way, sequential, in the sequential order, then the product will be really good. So we were discussing about the organization and decomposition also in that. So in this methodological evolution, there are 2 methods where we approach. Because yesterday we were discussing in this methodology traditional approach, what happens, there are few things which results in the delay of the product development. Yesterday, for that we were taking example. We are able to launch the rockets, we are able to build the satellites, we have built the rockets, and we have launched the rockets, even missiles, everything, but still we are not able to make a good impact in building the aircrafts. Means, I say India, we Indians, we have built the satellites, our own satellites, built the rocket, missiles, we have launched it, missiles also, everything is we are going, especially in the space related. But whereas in building a good aircraft, till now we are not that much successful to make a very good impact in the international level, in the world level. Still we are facing the problem. See, this is the example of when we go with a traditional product design and development process. See, there may be various reasons why we are not that much successful in aircraft. That may be related to the cost factor. When we purchase from others, it may be lesser cost than the building our own, using our own design. That may be one of the reason. I do not know exact reason. And another reason is yesterday we were taking in our project, 4 students will be there. Just now that Tilak is there, right, in your class. His batchmate, one of his batchmate in this project, he just called me today morning, and he was telling that they are not able to arrive at a common conclusion. Means, when only 4 students are there, where you have made the group by yourself, still so much problems will be there. Now you think of the organization, so many problems will be there. There is lack of communication. Andre ನಾನು ನೀನು ಚೆನ್ನಾಗಿ ಮಾತಾಡ್ಬಿಟ್ಟು ಬಾರ ಕಾಫಿಗೆ ಹೋಗೋಣ, ತಿಂಡಿ ಹೋಗೋಣ, ಅದು ಇದು ಅದು, that is different. Means, where we exchange the information in the product design process or the product development process. all those things will be there. So that will result in the delay of the product development. So to address those problems, the other methods have been developed by especially some of the companies. See, there are various companies. Now, one is concurrent engineering. Concurrent engineering, it is also known as simultaneous engineering. Simultaneous engineering. See, in the examination, they may ask like you write a short note on first one concurrent engineering, second one DFX. The question may be like that, or in simple words, discuss about concurrent engineering, like that. The question will be there. See, concurrent engineering is also called as simultaneous engineering. See, we discussed in the product design. How many steps are there? 7 steps are there. It may be product design or the engineering design. It is 7 steps is there. In the traditional product design and development, we go in a sequential order. First, once the step 1 is completed, then only we go to step 2. Once the step 2 is completed, satisfied, then only we go to step 3. This is traditional approach till it is step 7. It is gone like that. But just now we discussed that there are many reasons why it results in the delay. Example of your delay in the development of aircraft due to because you need to go step by step. If any problem is there in one step, you cannot go further. That is the one thing. Or sometimes you may assume that something is going to happen here, and you may stop there itself. That is one thing. And another one is lack of communication. Such problems will be there, and inefficiency, incapability of all those things will be there, or they may not be able to understand what is the exact requirement in one of the stage, like that. They may think that okay, if I do like this, something else may happen. They will not discuss with the next stage of people or the previous stage of the people what will be the solution. So this simultaneous means all the steps will happen at a time in a simultaneously, parallelly. It will happen parallelly, but there will be a good coordination will be there. See, why? Because we are discussing this from past 3 to 4 classes. Past 3 to 4 classes. Earlier, they used to go on paper, the design work, drawing work, everything they used to do it on the paper. If now I have done the drawing, and now there is a change in the tooth thickness of the gear, again the entire drawing has to be redone. Before redoing the entire drawing, the design calculation has to be done for all the things. Again, there may be a lot of changes. Again, the design itself, iteration process will keep on taking place. Everything on the paper, you just imagine how much time it may take, because man is a human being. He cannot work 24 hours in a day. He needs rest. He may get tired, fatigueness. Sometimes due to the repetitive work, he may feel that who will do this. Finally, he said, no, I can't do this. All those problems will arise. But nowadays we are using the computers, various tools are there, equipments are, many facilities are there. Yesterday we were discussing about this in your analysis, generation of nodes and elements, meshing. It can be done. It can be done. See, for the further analysis. So even in the drawing also, you can keep a copy, and in the copy, another the second copy, you can make whatever the changes is required, what you have planned now. The original copy will also be there. You need not have to redo the entire drawing. Means so much work burden is reduced. Means by using all the modern present day facilities available, see, it's comparatively easy to go with the simultaneously working on all the steps. If there is any changes, if they identify any critical point, any one of the steps, means they can easily communicate to other people. See, by understanding that the problem in the communication will act as a hindrance or the barrier for the development of a good product. Once you understand this, means you can easily communicate with all the peoples who are involved in the product development, and it can be done. Means so that there will be a effectively you can design. See, there will be various teams involved in this, so these things can be discussed, that can be interconnected, and that can be done in case of concurrent engineering. See, just now I said that earlier days everything they were doing on the paper. After you are and you identify that okay, there is something to be added or removed or corrected, then if you go back to the step 1, again you have to come through the entire process till 6 or 7. Means it used to take a lot of but or if earlier days you were doing the parallelly, everything parallelly, now there is a changes required. Again, all the people have to work again and again. So they used to go in a traditional approach, 1, 2, 3 steps, 1 step 2 like that. But now it's not like that. By using your latest tools, everything, you can do that effectively. So I hope you are able to understand why concurrent engineering means parallelly it can be done, and any changes required for cost effectiveness or simpler production, or it may be a effective design, or some changes required to be done for the improving the performance, or there may be a tolerance problem in this one, like dimensions, all those things, and there may be a method or approach taken to be less expensive to fix a certain problem, all those things. See, anything if you done, it can be done easily by using the various tools and equipments what we are using today. So because of that, we can easily go with this concurrent engineering. When we go with this concurrent engineering, we can design and develop a product very fast compared to earlier days. So you see, in all the automobiles, every year there will be some improvements will be there. Means the one which is coming out of the factory, at least there will be some changes will be there, improvements will be there. It will not be same product they will be giving for 10 years. Some improvements will be there. Why? Because they market. If there is some improvement only, the customer will be interested in purchasing. Okay, it's better. Or they will go to some other competitor product. And by using this latest tools, softwares, it's easy also to fix the problem. See, there are certain we call it as principles, essential principles, where concurrent engineering can be better explained. See here, highlighting the role of production process planning and its influence on the decision of the product design process. See, when the role of production process is highlighted much before starting of the product design process and its planning and its influence on the decision of the product design process. See, emphasizing the multidisciplinary dimension of the design team engaged in the product development process means multidisciplinary approach. See, it's you can take like very good examples. Earlier days, if the car is there, the passengers used to get into the cars, close the door, and driver used to start the vehicle, and they used to just drive it. Then later on, due to some reasons, they came with this door lock feature. When the driver is driving, someone may open the door and jump out, or unexpectedly the door may open and some of the passenger may fall out. You can have different thoughts, not fixed to any one thought. The passenger may purposefully jump, or by accidentally jump, or someone else may jump. Means all these things may happen without the knowledge of the driver. If the driver is aware of that, he can stop the vehicle. Means, so then there was a door lock system came into the or maybe for the purpose of theft, safety, everything. Nowadays, you know that when the car stops, the door lock gets automatically opened. And once the car starts moving and it reaches certain speed, different companies have put different speeds, some 20 km/h speed, the door will get locked by itself. If the driver is not wearing the seat belt, the dashboard will start giving the indication, some beep sound or buzzer sound will be made. And with respect to your speed, everything, there are many features which is happening. Your EBS, electronic braking system, body stability, your airbags. Not only that, even with the focusing of the headlights. See, if you just have a mechanical approach in design of all these things, it's not possible to have a good product, because you are using this engine management, microcontrollers for the engine management, controller for the washing machine, controller for the refrigerator. Yes, even without the electronic parts, components, the automobile, refrigerator, or your washing machine, they will work fine. But by integrating this also, the performance or effectiveness or the efficiency will be improved a lot. Better control systems will be there. Nowadays, we cannot think of developing any product without the integration of other branches. So there, the team must have the people with multidisciplinary dimension, where they will be having knowledge of different areas, so that they can integrate all the things. See, if you take the civil engineering, earlier days, they were doing all the things manually, mixing of the cement, building everything. Nowadays, they are using all equipments, earth moving equipments, some machineries in the construction industry, lift, cranes, everything. If they had said that no, we will do everything manually, they cannot build the high-rise building. It's very difficult. Similarly, in the laying of road, pavement, everything, everywhere they're using, means there must be a multidisciplinary approach has to be there. And in this concurrent engineering, sufficient attention has to be given for the customer demand and satisfaction. And there also be in mind about the reduction in the development time and time to market, the product to the market, that is time to market as a factor of product success and competitiveness. Since from the first class we are discussing the product has to reach in time to the market. If we just take the present pandemic situation in the newspapers, news media, we can see that they were talking about this remdesivir injection. There is a severe shortage of remdesivir injection and also oxygen, all those things. If those things are made available to the patient in the right time, the patient will get a very good treatment. Means he can recover very early. If it is not provided at all, because we came across this Chamrajnagar hospital due to shortage of oxygen for some 5 or 6 hours, some 20 plus patients died. It's a very sad thing. Nobody will be happy listening to that patient died because of some fever or due to some lack of facility. Nobody will be happy, including me and including you students. Nobody will be happy. So means if the oxygen has reached in time to them, they have got the oxygen in time, all of them have survived. At least 90% of the people have survived. Any one of you will agree that 90% of the patients would have survived if they had got the oxygen and also the medicine. Means also to our mechanical products, that may be the washing machine, refrigerator, automobile, or it may be a watch, it may be a some lift or weightlifting machines, or you take any product, mechanical product or any other product. If the product reaches the market in time, like you take your mobile phones, means our organization must be in pace, means must be also ready with the latest available technology or features as my competitors well advance in time, maybe early, or at least at the same time I must be there in the market with the improved features, improved technology, everything else. My competitor will be ahead of all the features, functions, technology, and price effectiveness. Sure, the customers will go towards them. So we can understand all these things effectively. See, I will draw one graph. See, our Tilak can also give a very good example for this. Tilak, idena online? See, if you look into the diagram written on the board, the cost impact will be there. See, means here I have written concept development. The delay in the concept development will impact on the product decision, because you are not yet developed the concept. Then now you can decide about the product. Then detailed decision design. There is a delay in the detailed design. It will affect in production decision. Planning and tooling. Delay in planning and tooling. It will affect management controls. Then delay in the manufacturing. Manufacturing means to make all the facilities ready. That affects in production optimization. See, the delay in the concept development will be the cost impact on the decision will be very high. There may be delay in manufacturing, but the cost impact will be comparatively less when compared to the concept development. Means that is explained by this curve. So the cost impact of making a design decision will affect like this. See, if we the next one is characteristics of concurrent engineering. See, there are few characteristics which influence the concurrent engineering. Like we will first try to understand the advantages of concurrent engineering. Advantage means it reduces the product design and development time. Why? Because we try to understand all the steps will be done parallelly. All the 7 steps will be done parallelly. So we can reduce the product design and development time. But and also by proper coordination between all the teams working in the different steps, we can limit the product redesign and we can make the product reach the customer in lesser time. Means if we save the time, the cost will also reduce. How the cost will reduce if we save the time? See, when you set up any manufacturing facility, from the day you start that, the money investment will be happening on that, and people who are working that, they have to be paid the wages, everything will be the investment that is made by the management. Means the interest will be happening with that, and there will be a uncertainty factor with the delay. Uncertainty also increases. The increase in the uncertainty will add up to the huge allowance. Means the total investment will be more. So any person of the management who invest as a entrepreneur, they want to get the returns, because you have done this engineering cost and estimation, or the subject you have studied, the payback period, all those things you have studied. Means to take back that means the interest burden, everything will be more. Means finally the cost of the product will increase. So if you can design, develop and make the product with lesser time, means the cost will be less. The cost of the raw material will be same, but whereas the overheads will be less. See, raw material cost will not change at any cost. Even with the increase in the production rate also, raw material cost will not change. But the overheads will change, reduce. Thereby, it will be more beneficial for the customers. And also, if you increase the production rate, means with the vendors, the price can be negotiated. See, we were with the advantages. It enhances the productivity through by early design, and if any issues are there with respect to the design problems, that can be understood very well early, and it can be rectified also, so that there will be no much problem at the later stage of the production process or the development process. Means if we go in the traditional way, step 1, step 2, step 3, some problem you identify in step 6, again you have to come back to, you may come back to step 1. But when we go parallelly, concurrent engineering, that all those things can be reduced. It helps in reduction in time to market and gain advantage over the competitors, and facilitates the rapid response to fast changing customer demand. Fast changing customer demand is, see, whatever you give to the customer in the product, whatever the features you give, still the customer want more features, more function. No customer will say that, okay, for the price what I have paid and what I am paying, I'm happy, satisfied with the features and function. They will never say. And every day they will be looking, okay, my neighbor has this one, something, a car. I want the much better than that. No customer will say, no, I don't want the better product, I want the inferior product. No customer will say like that. It is the human tendency to compete among themselves only for the show off. They will say, oh, I must have better than him. But one thing is, the students among you are the good persons, students. You never say that I must score more than another student. I must score more than the topper. You peoples never compete like that. So in terms, if we see in that way, our students, mechanical students, are very good. They won't compete, especially in academics. And with the concurrent engineering, it improves the product quality, because if there is any problem in any of the stage, it will be communicated back to the entire team, so that it will be taken care. So improved product quality will be there, and actually a good communication is required, so it facilitates a very good teamwork. So if your project team, if you have very good teamwork, means you can do very good project with lesser time, like that. And if there is no proper coordination among you peoples, you will be facing listening to all the scoldings from your guide and coordinators. See, but there is some limitations also for this concurrent engineering. See, it can be effective when all the design activities are performed in a parallel and